In this video series, I would like to design a 12-volt uninterruptible power supply for my router because we've been experiencing power outages, and at least I would like to have internet during these power outages. And in part 1, I will talk about battery pack and cell protection. But why do batteries need protection? No, not that kind of protection. I'm talking about overvoltage, overcurrent, undervoltage, and over temperature protection. Batteries nowadays store a tremendous amount of energy, which has to be controllably charged and released. Otherwise, in best case, they become unusable or lose some of their charge. In worst case, they blow up. These are just standard 18650 cells without protection. This is nickel cadmium, I believe, also without protection. This is another 18650 cell, but as you can see, it's slightly longer. That's because at the bottom it has a protection circuit. I've cut open a similar cell, and you can see at the bottom there's a tiny circuit board, and it also connects through this ribbon to the positive side to measure the cell voltage. Smartphone battery cells also have a protection circuit. I think all lithium cells have one. Also, this tiny cell here has a circuit as well. These are so-called active protections because there's a circuit board and it actively measures conditions in the cell and charging and discharging rates. Power banks have protection built in. This is a different power bank circuit, and it has an integrated charger, discharge, step-up converter, and display driver. And I like this board because it has a fancy feature of showing you the approximate charge based on the cell voltage. There's not an exact correlation between cell voltage and remaining capacity, but it's a good estimate. For this UPS, I will be using these nickel metal hydride batteries, which come from old robot vacuums, and these have so-called passive protection. I've already cut up the protective sleeves, and as you can see, there's some sort of device here. Well, this is a polyfuse or resettable fuse. At a certain current, this heats up, and as it heats up, its resistance increases sharply, thereby lowering the current. And over time, it cools down and resets to normal conditions. And also, tucked away inside the cell is, if I can get it out, is a tiny thermal fuse. This is calibrated at 70 degrees. And it opens circuits when it reaches 70 degrees, thereby disconnecting the cell, or no, disconnecting the pack. This pack has a temperature sensor. This is just this NTC temperature sensor, again tucked inside the pack, and the charge controller can read the temperature of the pack through this temperature sensor. Also, this large nickel metal hydride pack also has a resettable fuse. Over here, this is a 4-point focus, please. 4.2 amps resettable fuse, because this is a higher capacity battery pack, and also it has a temperature sensor. But this doesn't have a thermal fuse, which I will install if I use it. In the next video, I will be designing a nickel metal hydride charger for these packs. I think I'll use this larger one because it's larger. Stay tuned.